Hi, Ms. Ramsar. So the question I chose was question number 1, and this question asked about how to find the final velocity. And basically in the question, a bear spots honey 16 meters away. He wants to go check out the honey. So and the question is asking, what is the final velocity? First, what we do in any problem is we list out all the variables we know and we don't know. For example, A, acceleration, is 2 meters per second squared. V of I is 0. V of F is what we're looking for, so that is unknown, hence the question mark. Delta X is 16 meters. And T, time was never given, and it doesn't really matter for this problem. So, now that we have all the variables listed and what we do and don't know, we implement it in the equation. The equation I chose to solve for V of F is V of F squared minus VI squared equals 2A times delta X. Now, because I've already listed all my variables, it's quite simple. All I have to do is input them into the equation. So after inputting them, I get V of F squared minus 0 equals 2 times 2 times 16. And after I distribute and solve for all of this, in the end, right before I find out my final answer, you get V of F squared equals 64. And to cancel it out to get our problem, we have to square root this all. So the square root of 64 is 8. Hence, V of F squared equals 8. That is our final answer. That is what final velocity is. Now, what we also should do is put a motion diagram. This is my motion diagram. As you can see here, it's the bear, and this is the honey. So the bear moves 16 meters towards the honey, but he also moves at an acceleration of 2 meters per second. So I put this 2 arrows here with pauses to show that he's accelerating. The shorter an arrow, the slower it is. The longer the arrow, the faster it is. So this here is what we were looking for, which is the velocity of 8 meters per second squared. And what we also should do is implement a velocity time graph. So this is my simplified velocity time graph. It says in the problem he's accelerating, so that means the velocity would also be accelerating. I'm sorry, that was a bad line. It would also be accelerating. So that is a simplified version of my velocity time graph. And that is all.